Alan and Cassandra are, I know it could be Cassandra, but I don't care, are traveling towards each other from points that are 122 miles apart. If Cassandra is traveling 1 mile per hour faster than Alan, they meet after 2 hours. How fast was each traveling? So this right here is a rate. Their speed is always a rate because it's a distance divided by time situation. Okay, so I know I'm looking at some kind of d over t situation here, I guess. They are they're traveling towards each other. So again, this time, perhaps it could be a subtraction situation on this one, but we'll see. So we got two people. Let's see how this goes, right? I do know that I got Alan. And then on the other hand, we have Cassandra. Okay. And we're going to take those rates. I guess our final situation here is that they meet after 2 hours. So that's our time on that one. I don't know. Right now, just having set it up as rate, I don't know that that's going to be the case on this one. This would mean that they both did travel 2 hours, though. I'm going to put that in. I will. So, okay. So if I looked at the distances, I mean, it looks like they both traveled 122 miles, right? My problem here is that so yeah, they're not actually traveling the 122 miles. You see the importance of reading these and rereading them, right? Plus, if I did that, if I said, well, if I set it up with this rate equals distance divided by time business, not only do I not know how long or how, well, I don't even know the speeds necessarily, kind of. I can say that they're related to each other. But so we do know that Alan's speed, though, the rate for Alan is so 1 mile per hour. Oh, so there's two ways to do this. You can define a variable for Cassandra, or you can define it for Alan. I guess we'll do Cassandra. Is that right? So here's what I mean is C, I will say, is it want to know how fast the speed. That's Cassandra's speed. Okay. You can do Alan's, by the way. So my variable is including speed in there. So I'm kind of figuring the rate is not going to help me. Again, it's not helping me. It certainly is not helping me set up these fractions with distance divided by time. So I'm gonna regroup, and I'm gonna say, well, that's it's usually distance equals rate times time. And the reason why I'm going there is because we do have a time, right? They're both going to travel 2 hours. And then we do have some kind of relationship with the rates, at least, all right? For example, Alan's rate, or Alan's speed, his speed is like taking Cassandra's, but he's going slower, right? Because she's 1 mile per hour faster, so you'd have to take Cassandra's speed and take one mile per hour away from that. Cassandra's speed is just Cassandra's speed, C, right? That's what we defined it as. And then we found the rates, and then we would multiply that by the time. We know they did both travel 2 hours. So I can just multiply both of these then by 2. Yeah, see how that's kind of setting up pretty good, right? And then the distance that they're going to travel together. So the distance they travel together, yeah, it's set up here is 122 miles apart. But they're both traveling towards that distance, so I'm pretty sure we're adding those two distances. Alan's distance plus Cassandra's distance ends up being a total distance of 122 miles right there. So let's go ahead and get started solving this equation. So let's go ahead and distribute then, because we do have that distribution of the 2. So 2 times c is going to be 2c. 2 times -1 is -2. Of course, we still have everything else. And from here, I can look for any like terms combined. I got the c's, right? So 2c's plus 2c's is 4c's. Now I've got -2, and that's a positive 4c. is going to equal 122. So some principles of equality now. I'm going to go ahead and zero out that -2, so add 2 to both sides. Okay, so that does zero that out. I can drop my 4 C's, which now equal 122 plus 2 would be 124. And then last thing here is to make that coefficient of C a 1. So that's going to show a phantom 1C, but I would divide both sides here by 4. And 124 divided by 4 appears to be 31. Now C, again, what is C? C was Cassandra's speed, right? So that's 31. It appears that they were driving in miles, and this was in hours. So this is also 31 miles per hour, but that's for Cassandra. Okay. Well, Alan is going 1 mile per hour less than that. So Alan's, we're going to take Cassandra's at 31, and we just got to take one away from that. Okay, so Alan then is going 30 miles per hour. So this is Alan's speed right here, and this is Cassandra's speed. Okay, well, if this is true, can we actually check? Well, they met after 2 hours, right? So the distances come together. Alan then traveling 30 miles per hour, which we already figured out C minus 1. 30 times 2 tells us that Alan then, he would have traveled 60 of those miles. Cassandra, though, she's at 31 miles per hour, so 2 times 31 would have been 62. And yeah, if you take 60 and add it to the 62, you will get 122 miles of distance.